right, so we are back at AP Review. We're doing 2017 AB for response 6. So the first thing you should notice when you open this problem is like, holy cow, calculus just threw up on a piece of paper. This has got everything, right? It's got the graph that has convenient geometric shapes, it's got an equation that you're going to have to do stuff to, and it's got a table. But the trick is that all of them are for different functions. So what's really complicated here is they're going to ask you to do things with h, which is the graph. They're going to ask you to do things with g, which is the table. We have both g and g prime. And they're going to ask you to do stuff with f, which we have an equation for. So when you look at this, it's like the AP writers just couldn't decide what they were going to do. So they're like, hey, let's just do absolutely everything that we could make a person do by giving them 3 separate functions. So let's have some fun. All right, cool. Let f be defined by this equation, right? Let g be a differentiable function, there's the table, and let h be the function whose graph consists of these line segments right there. It's much better on the real paper than it is on mine, so please use the real paper. Cool. A, find the slope of the line tangent to the graph of f at x equals pi. So part A is asking me to use f, right? Part A is asking me to find f prime of pi. So I first need to find f prime of x, right? F prime of x is going to be derivative of cosine, which is negative sine of stuff times the derivative of the stuff. So I'm going to get negative 2 sine of 2x plus the derivative of e to the x is e to the x times the derivative of the stuff. So I'm going to get an e to the sine x, right? Cosine x, because that's the derivative of sine. They asked me to find f prime of pi because they said the slope of the tangent line at pi. So that's going to be a negative 2 sine of 2 pi. Plus an e to the sine of pi cosine of pi, right? Well, sine of 2 pi is 0, right? And sine of pi is also 0, so I end up getting 0 plus e to the 0 times cosine of pi is a negative 1, so I end up getting that the slope is a negative 1 times a 1, which is a negative 1. Part B, let k be the function, oh my, they gave us another function? So nice of them. Let k be the function defined as h of f of x. Find k prime of pi. Fun! Okay, so this is testing your knowledge of the chain rule. So, oh, I didn't mean to erase our f function. Oh well, we'll deal with it in a sec. Here, wait, I'll rewrite it, because I did not mean to erase f. It was cosine of 2x plus e to the sine x. My bad. Okay, so part B, right? K of x is h of f of x, right? So k prime of x is going to be a chain rule, right? The derivative of the outside, which would be h prime of f of x, times the derivative of the inside, which would be f prime of x. So they want k prime of pi. Well, that's going to be h prime of f of pi times f prime of pi. Now we already found f prime of pi, right? This was our answer to part A, right? This is our part A answer, so part A. We know that this guy is a negative 1. Great. Now we need to find h prime of f of pi. So let's find f of pi first, right? So f of pi should be cosine of 2 pi plus e to the sine of pi, right? Sorry, inching that over for you. So that's a 1 plus an e to the 0, so I get a 2. So this is h prime of, so this is actually h prime of 2, right? So my k prime of pi, h prime of 2, if you go to 2, right? H prime of 2 is the slope of this graph at 2. So if you want to find the slope of this graph, you do rise over run. This thing rises negative 1 and goes over runs 3. So h prime of 2 is a negative 1/3. So you're going to get that this is a negative 1/3. That's not what I wrote, though. Negative 1/3 times a negative 1. So you should get 1/3. So your k prime of pi is a 1/3. Good times. All right. So nice of them to introduce a 4th function. Oh my goodness, here comes function number 5, right? Because we had g and g prime and h and f. Oh no, sorry, we had g, well, if you consider g prime its own function. Anyway, we're on function 5 or 6. This problem is throwing the whole caboodle at you. It's crazy. All right. C, let m be the function defined by m of x equals, so in part C, and I'm afraid to erase any of this in case we need it, m of x is g of negative 2x times h of x. they ask us to find m prime of 2. So this is a product rule, right? UV, and that's also going to be a chain. So m prime of x is going to be u, which would be g of negative 2x, dv, which would be h prime of x, plus v, which is h of x, du, which would be g prime of negative 2x times the derivative of the inside, which is a negative 2. Great, super fun. Okay, so now we're going to start to use all that information. So they want m prime of 2, so that's going to be g of negative 4 times h prime of 2, which we thankfully just found, plus h of 2, which we can see in a sec from the graph, times g prime of negative 4 times negative 2. Okay, fun. So let's walk through this. So I can get g of negative 4 from the table. G of negative 4 is a 5, right, from the table. H prime of 2, oh, I'm sorry, we didn't find h prime of, oh, yes, we did. We found h prime of 2. We found h prime of 2. It was the negative 1/3, right? We found that as part of the last one. H of 2 is the physical y value here. Now, that's going to be a little tricky because it might not be the nice, happy y value that you want it to be, right? Since this is a slope of negative 1/3, if you go over 2, right? So, like, essentially, the triangle you're looking at is over 2, and then the question is, what is this y value, right? So the ratio of these things is essentially, so negative 1/3 equals some y value we don't know, right, over this run of 2, right? So when I clean this up, I end up getting that negative 2/3 is my y. And you can think about that any number of ways. It's fine. So I get a negative 2/3 for my h of 2, right? G prime of 4 I can also get from the table. That's a negative 1. And a negative 2 that was already sitting there. So when we clean this up, again, there's like no good spot to do this because holy cow, this problem has a lot going on. So if I clean this up here, right, m prime of 2 should be a negative 5/3, right? And when I multiply all this stuff together, I think I get a 4/3, right? So after all of that ridiculous amount of work, I should get negative 1/3. Did I miss a negative? Oh, hey, that's 3 negatives. It's not a plus 4/3. My bad. Huh. Sometimes adding is hard. Negative 9/3, which is a negative 3. My bad. Sometimes adding is hard. So it's the worst when you do all the calc right and then just can't add. Awesome. Okay. Finally, part D. Is there a number C in the closed interval from negative 5 to negative 3 such that G prime of C equals negative 4? Justify your answer. Okay. This is, so when they ask these questions about whether something must be true, that's asking about a theorem, right? So their question was, in part D, in the interval from negative 5 to negative 3, is there a C such that G prime of C equals negative 4? Okay, we were told that, so, one, we know that G is differentiable, which implies continuity, because you can't be differentiable without being continuous, right? So we know G is continuous, we know it's differentiable, and we know that if we were to find the old school slope, right, old school slope on the window they gave us, right, the old school slope for G from negative 5 to negative 3 would have been G of negative 3 minus G of negative 5 over negative 3 minus a negative 5, right? Well, that would be G of negative 3, which is 2, minus G of negative 5, which is 10, all over a positive 2. That's a negative 8 over 2, which is a negative 4. So, by the mean value theorem, which totally applies, yep, the answer is yes, right? So the mean value theorem applies because G is both continuous and differentiable, and because when you find the old school slope between these two endpoints, you get the negative 4 that's listed. So yes.